Hi, my name is Chibun Kim Oninanya, and this is my physics lab for discussing circuits. So to introduce the lab, a circuit is a closed loop that electrons can travel in, and there is a charge and energy conservation in circuits. The fundamental concepts we'll be talking about today includes Kirchhoff's law, Ohm's law, and RC circuit. And on the right, you will see the formulas for Ohm's law and Kirchhoff's law. The purpose of the lab is to predict the behavior of circuits containing resistors in series and parallel. Use multimeters to measure the actual values of conventional current and potential differences in circuits, and examine the behavior of the ohm resistors and capacitors. And the results, there's actually 3 different experiments that we went through. The first experiment, the voltage was 3V, and the resistor and ammeter values were 0. And in the second experiment, the RC was 5.92 seconds, and the experimental was 6 seconds. So the models we'll be using is the RC circuit, the series circuit, parallel circuits, and the PHET simulator. And those are just some pictures of the different circuits that you'll see. And the assumptions we used were that there was no wire resistance because we used a computational model, and the ammeter resistance is also negligible. So the experiment, in the experiment, the system is the circuit that contains the electrons moving, and the surroundings include the battery and the ammeter. And in the experiment, basically, a circuit was created by placing a wire and connecting that wire to batteries, resistors, and an ammeter. The initial conditions in the first experiment, it was 2 1.5 volt batteries, 2 resistors of values 1.5 and 1,000. In the second experiment, it was 1 9-volt battery, 1 light bulb with a value of 10, and MF capacitor with a value of 200. And in the third experiment, it was the exact same values, except the light bulb had a value of 30. So for the discussion, in the first experiment, the currents had a value of 0.02, and to calculate the net, basically we added up all the different current values, which, as you can see, is only 3 have a non-zero value, which is A, B, C, D, and E, F, and those add up to 0, so that is correct because that's what we wanted. And in experiment 2, the charge time was twice the charge, and as voltage rises in charge, the bulb dims until it gets to 0. And in experiment 3, the slope was negative 0.1689, so the RC was 5.91 seconds because the RC is equal to negative 0.1689 minus 1 over RC. So once you do basic algebra, you'll get 5.91. And the model RC is 6 seconds. So my value is similar, but it's less than the model. And source of error to produce that difference in my value and the model can be from rounding error or inputting the data in Excel, because that's where I got the slope from. And finally, to conclude the first what-if question, the ammeter would provide resistance because of the material it is made from. So the resistance would be larger than 0, and it will be positive, which will affect the data. And the second what-if question, kind of similar, but in a real-life example, it would take longer for the ammeter to charge the capacitor. And this is because, like I said earlier, the resistance will be accounted for, unlike how we did the experiment today, which there was no resistance because it was a computer model. And the results, once again, were the voltage in experiment 1 was 3V, the resistor and ammeter values were 0, and the experimental RC was 5.92 seconds, while the model was 6 seconds. Thank you very much. And that was the lab.